Hi everyone. Welcome to the Geeky Minds, your source for things related to system design and back-end development. If you are new here, I'm Gourav, a back-end developer and your new friend in the tech world. Let's explore and learn about system design and back-end development together. Don't forget to check out my blog, https://thegeekyminds.com for even more great content. And please don't forget to like, comment, and most importantly, subscribe, so we can continue this amazing journey together. So grab a cup of coffee, kick back, and let's get started.
How WebSockets are different from HTTP/HTTPS. Today's fast-paced, data-driven environment has made real-time communication between applications and devices a critical part of cutting-edge web applications. HTTP and WebSockets have emerged as two essential methods of communication. Client-server interactions routinely employ both protocols, despite their differences. This video compares and contrasts HTTP and WebSockets, focusing on their core architectural and operational differences. Whether you're an experienced web developer or just starting out, this video will give you crucial insights into the world of real-time communication and help you choose the correct protocol to employ in your projects. Let's dive right in. What is HTTP and HTTPS? On the World Wide Web, data is transmitted and received using the client-server protocol known as HTTP, Hypertext Transfer Protocol. A great majority of websites and web applications use it as the foundation for data transfer on the Internet. A secure variant of HTTP, known as HTTPS, Hypertext Transfer Protocol Secure, uses encryption to protect the confidentiality and security of data transferred over the Internet. How HTTP/HTTPS works. In HTTP, the client, such as a web browser, submits a request to the server, which then returns the desired data. Request and response are structured into a structure called a message. HTTP messages typically include headers, request or response-related metadata, and a body, the actual data being transmitted. A client sends an HTTP GET request when requesting data from a server, and an HTTP POST request when sending data to a server. In HTTPS, client-server communication is encrypted using SSL, Secure Sockets Layer, or TLS, Transport Layer Security protocols. This provides an additional degree of protection for the sent data. Constraints of HTTP/HTTPS. HTTP and HTTPS are designed for web-based communication, but their constraints make them unsuitable for real-time applications and other high-performance scenarios. For instance, latency. HTTP/HTTPS is built for request/response communication, which may cause a significant amount of latency. Consumption of bandwidth. HTTP/HTTPS could be wasteful in terms of bandwidth use because it sends vast amounts of overhead data with each request and response. Due to the unidirectional nature of HTTP/HTTPS, the client must establish the initial connection with the server. The applications that can be created utilizing these protocols may be constrained. In conclusion, HTTP/HTTPS are widely used and well-matched for many applications, but their constraints make them less appropriate for real-time scenarios. Here, WebSockets come into play. What is a WebSocket? WebSockets are a full duplex communication protocol that permits bidirectional, real-time communication between a client and server over a single, persistent connection. WebSockets, unlike HTTP/HTTPS, which is built for request/response communication, allow for continuous client-server connection. This makes WebSockets ideal for real-time applications and other high-performance scenarios. How do WebSockets work? WebSockets function by creating a persistent connection between client and server. Once this connection is established, the client and server can transmit and receive data without a request-response cycle. This enables nearly instantaneous communication between the client and server, hence lowering latency and enhancing overall performance. Key WebSockets advantages over HTTP/HTTPS include real-time communication. Bidirectional, real-time communication between a client and a server is made possible via WebSockets. This makes WebSockets ideal for real-time applications and other high-performance scenarios. Low latency. WebSockets minimize latency by allowing continuous client-server communication without the need for a request/response cycle. Bandwidth efficiency. WebSockets consume far less bandwidth than HTTP/HTTPS since they just send the data that has to be communicated and don't incur the overhead of a request/response cycle. Bidirectional communication. WebSockets allow for two-way communication between a client and a server, which opens up a wide range of application possibilities. WebSockets, in conclusion, offer a robust and efficient alternative to HTTP/HTTPS for real-time and high-performance client-server communication. Whether you're building a real-time chat application, a stock ticker, or a gaming platform, WebSockets are a technology worth considering. Differences between HTTP and WebSockets. WebSocket is a bidirectional, real-time communication protocol between a web browser and a server. HTTP, Hypertext Transfer Protocol, is a protocol for transmitting and receiving data across the Internet. WebSockets and HTTP are both Internet-based communication protocols, but their key characteristics make them suitable for different sorts of applications. Connection type. HTTP is a request-response, half-duplex, protocol. This indicates that a client, such as a web browser, submits a request to a server, which then returns a response. Each request and response is independent of the others, and the client-server connection is severed following each transaction. HTTP is well suited for applications that send little amounts of data occasionally, such as web page loading. WebSockets, on the other hand, are a full duplex protocol, meaning that both the client and server can transmit and receive data simultaneously, without the requirement for a request-response cycle. WebSocket is therefore well suited for applications that often communicate massive quantities of data, such as real-time multiplayer games, chat applications, and stock tickers. Latency. WebSockets use a single connection that remains open during the communication, whereas HTTP requires a separate connection for each request and response. WebSockets are intended for low latency, high-frequency communication, while HTTP is better suited for bigger, less frequent data transfers. Bandwidth usage. WebSockets utilize less bandwidth than HTTP. The reason is WebSockets establish a lasting connection between the client and server, which enables bidirectional communication without the need for continual reconnection. In addition, WebSockets do not incur the expense of establishing and closing a new connection for each message. Use case. WebSocket enables faster and more efficient communication in use cases such as online gaming, chat apps, and real-time data streaming. Whereas HTTP is normally used for web pages and other static material. Security. HTTP lacks built-in encryption and requires the implementation of extra security measures. WebSockets employ the same security methods as HTTPS, HTTP Secure, which encrypts client-server communication. Data format. Another distinction is the manner in which data is transmitted across the connection. The HTTP protocol transmits data in a structured format, such as JSON or XML. WebSockets use a binary format for data transmission, allowing for more efficient encoding and decoding. This also makes WebSockets more appropriate for transmitting raw binary data like graphics, audio. In conclusion, both WebSockets and HTTP are valuable internet communication technologies. However, they offer different functions and have different capacities. HTTP is a request-response protocol commonly used in online applications for sending and receiving data. It is simple, reliable, and supported by a large number of browsers and servers. WebSockets, on the other hand, is a more advanced protocol that permits bidirectional, real-time communication between clients and servers. Applications requiring low latency and high-frequency data transfer, such as online gaming, chat applications, and live streaming, can benefit from their deployment. Overall, the choice between the two protocols will depend on the application's specific requirements and the trade-offs between simplicity, dependability, and real-time capabilities. And that's a wrap. Hi, I am Gourav Dhar, a software developer, and I create content for back-end development and system design. Subscribe to my YouTube channel and learn something new every week.